Hi folks, in this video we learn about conditionals in formal logic. So what I want you to do is pause your videos and see if you can remember this terminology from the reading. Tell me, what is the antecedent, what is the consequent, and what is the conditional in this formula? Okay, that was your chance to pause your videos. The antecedent and the consequent are clear. The antecedent is just the thing that comes at the front, the beginning of the conditional, before the arrow, and the consequent is the thing that comes after the arrow. Now, the word conditional is a little trickier. This is ambiguous, but context will pretty much always make it clear what we mean. I'm going to call this arrow symbol the conditional. Sometimes I'll call it the conditional, sometimes I'll just call it arrow. But also, we're going to call this whole sentence a conditional too. It's a conditional sentence. And a conditional sentence, that just means some formula of a formal system whose main connective is a conditional symbol or an arrow. Now, besides the conditional, there's also the biconditional. And language can be your guide. Biconditional just means the two conditionals. It means a conditional going from A to B and from B to A. Now, the antecedent consequent terminology is a little complicated with this one. I mean, A is both an antecedent and a consequent, and so is B, just because their conditional is going in both directions. Now, what are we doing? We are creating a new logical system called prop. Strictly speaking, prop is an extension of bool. So everything you've learned previously in the class is still applicable. This is going to hold good for the entire quarter. All we're going to do is keep building more and more complex logical systems that add more and more stuff to what you've already learned. So nothing that you've ever learned in the past, you have to forget or unlearn. And as well, that's why it's really essential to master all of the skills as we go along, because the cumulative nature of the course makes it really hard to just catch up and cram it in all in at the end. So besides, you'll notice the language semantics and formal proofs have all the Boolean stuff. We've got the Boolean connectives down here. We still have bivalence just the same. The meanings of those Boolean connectives don't change. But what the conditional and the biconditional are new truth functional connectives that we're adding to the language. You may remember from one of the previous videos, we said we're not going to add any non-truth functional connectives to our formal systems. They're all going to be truth functional. And I'm only going to call not, and or the Boolean connectives. So we're going to call the conditionals different truth functional connectives. They're not Boolean ones, but still they're going to be truth functional. That means that we can capture their semantics with truth functions, just like we did for the Booleans. And of course, I hope you see where we're going. Of course, we're going to start doing formal proofs with this system once we understand it as well. So it took us 5 weeks in order to fully master the system bool. We're going to start moving a little quicker because now you know what a logical system is. You know it has these 3 parts. And it's going to be a lot easier to build more advanced systems now that you have that foundation. Prop is such an important logical system because there are many ways of expressing conditionality in English. And we actually use this sort of conditionality in our reasoning in everyday life a lot. And that's why prop is going to be a very helpful tool for understanding how we reason. Here's some examples. Like, if you study logic, then you'll succeed in life. That's a kind of conditional relationship between studying logic and life success. Or the word if can be buried in the sentence like this too. You'll get an A if you turn in all your work. This sentence is positing a kind of relationship between your grade and A and what homework you do. But if is not the only way. Notice if appears in a lot of these, but not all of them. Whoever studies logic will succeed in life. This sentence as well posits a kind of conditional relationship between studying logic and life success. So there's many ways in which conditionality can be expressed, and we're going to see how to translate all of these into our system prop. Now, let's start with the basics. Pause your videos and see if you can translate this one. So here's the sentence. You will get an A if you turn in all the homework. And I've given you some definitions of what the atomics mean. So pause your videos and pick one of these options. All right, let's start talking about the answer. This one is H arrow A. So the lesson I want you to take away from this is you can't just follow the order of the sentences in English and assume that's the order in prop. So in English, the A appears first on the furthest to the left, but in the prop, H appears furthest to the left. So what you have to do is you have to think what kind of relationship is posited here. You have to think about the logical commitments of this sentence in English to figure out what the antecedent is. If you see the word if alone, just if, like I've underlined here, then that signals the antecedent comes next. When I say you will get an A if you turn in all the homework, what it means is if you do that thing, turn in all the homework, then you are going to get an A. So you could rephrase that, putting the antecedent first if you would like. that helps see more clearly that H arrow A is the right way to translate this. Okay, let's do another one. Pause your videos here. I've changed the sentence slightly, but the atomics stayed the same. So tell me what the correct translation of this would be. All right, that was your chance. This one is not H arrow A. This one is different. It's A arrow H. So did this go in a different direction? Well, you'll get an A only if you do this. What that means is if you learn somebody gets an A and this conditional is true, then you know they turned in all their homework. This is possible only if this is also guaranteed. So you have to think about what kind of relationship is posited. If I know something over here, does that guarantee me that I could also know this? That's the kind of thing that will help you reason through these translation cases. Another point to make, I said that if always signals the antecedent, but it's really important to emphasize when you have if alone, it signals the antecedent. So only if is different than if alone. Only if is really treated as a package, as a chunk that you can't break apart. And what this signals is, that the consequent comes next. So you read only if just like this were an arrow sentence. This is an important one to really internalize, because only if can sometimes trip people up. Let me say translating the biconditional is generally straightforward. Our canonical translation is going to be if and only if. So what that does is it captures the if clause going in one direction and the only if clause going in the other direction. The biconditional, if you ever get confused and wondering what the symbol means, just remember it's really just a conjunction of two separate conditionals. Here's another way in which you could convince yourself that the translations of if and only if ought to be different. If and only if, this is not redundant, but if and only if were translated exactly the same, then this would be redundant. Let me make one more point about translations. We're going to stipulate the words just in case is also going to be translated as a biconditional. This is like a technical term in logic and advanced mathematics that is just another way of stating the biconditional. So think of just in case kind of like our definitions of validity or soundness or other technical terms, which are used in many ways in English, but in logic, we're going to give them a very specific meaning. Well, this phrase could be thought of like that. Whenever you see just in case, we're going to translate it with the biconditional as well. One last bit of terminology. Remember how at the beginning of the quarter, when you started learning some logic, you just had to memorize, or you got dumped like 30 different terms on you? It was such a terminological heavy lifting. Well, it's sort of the same now that we're learning a new logical system. There's a bunch of terms that you're going to encounter at the front, but as we use them, as we start to do stuff with them, they will start to make more sense. Necessary and sufficient conditions. This is a common way of speaking in philosophy, in logic, and science. And this is also well captured by our conditional arrow symbols. So if something's a horse, then it's a mammal. Notice these are equivalent. It's also the same thing to say something's a horse only if it's also a mammal. So these two sentences in black really are synonymous, or they're the same thing. They're both translated H arrow M, and that relationship captures sufficiency. So what it means to be sufficient is the first thing guarantees the second thing. If the first thing is true, then the second thing also has to be true. So being a horse is sufficient for being a mammal. Necessary conditions go in the opposite direction. They're the converse. So this also captures a necessary condition, but what it is being M is necessary for being H. You can't be a horse without also being a mammal. So being a mammal, if something's a mammal, being a mammal is necessary for being a horse, which is another way of saying if something's a horse, it's got to be a mammal too. You can't satisfy the first part without also satisfying the second. So satisfying the second is a necessary condition on satisfying the first thing. Okay, so in this video, you encountered the conditionals and you learned some basic terminology and ways to translate things from English into our new formal system prop. Thanks.